This is a failover technique that one device will always be acting as primary firewall. Even after failover, if that device comes back up, it should retain its position as the traffic forwarder. Okay. Heartbeat backup. Okay. Now we discussed what split brain is, right? Split brain is when maybe this is not working currently. Just give me a moment. Okay. So split brain is when the control link between active firewall and passive firewall goes down. Then neither the active firewall, neither the passive firewall can see each other. So after some time, this will think, okay, this is down. And this will take the active role. Both will be acting as active firewalls then. But since the interfaces are common on the devices, there will be network outage. There will be IP conflict. This is what split brain is. Now, what heartbeat backup is? Heartbeat backup helps us to avoid split brain. What this will do, this will try to send control messages, not control messages, just ICMP messages over management connection to the peer device to see if that is up. Now, for this to work, there should be routing between management to management IP. First thing. Okay. Now, if I'm already using management connection for HA1 for the control link, I cannot use a heartbeat backup because it doesn't make sense to use heartbeat backup if I'm using management to management connection for the control link. Okay, so if I'm using HA1 dedicated port and HA1 dedicated port on both ends, and this goes down, I can enable heartbeat backup. What this will do, this will check the management connection on both the ends. This will try to see if the peer is still active, even when the heartbeat, even when the control link is down, HA1 connection is down. This is what heartbeat backup is. We will not enable preemptive HA timers. Let's see the timers. Okay. Now promotion hold time. This is the time the passive device will wait for before taking over the active role. If in case the primary device goes down. Promotion hold time. Hello interval. This is the control message that is being forwarded from active to passive and also from passive to active. Heartbeat interval. This is we discussed. Heartbeat is a simple ICMP message that is known as heartbeat. Flapmax. Let me see. What is the Flapmax? Okay, so the Flapmax is if in case a device goes from active to non-functional and then back to active and then again non-functional 3 times, this will go into suspended state because there is something wrong with this device. If this happens from active to non-functional, then non-functional to active 3 times, this will move into suspended state. So this is the flap max time for this. From preemption, hold the time. This is the time the primary device will take before taking the active role back from the secondary device. Okay, these two, let me check these. Monitor fail hold up time and additional master hold up time. Let's see what this is. So if we click on
Hi,
this,
Sanjay.
yeah,
What it was the promotion whole time? Can you repeat again?
promotion hold time. This is the time taken by the passive firewall to take over the active role when the active when the primary firewall goes down. Okay, so it will wait for 2 seconds.
Okay.
So you will see just one ping miss or two ping misses. Okay, so what did we left with? Monitor fail hold up and additional master hold up time. Let's see. Monitor fail hold up. Interval during which the firewall remain active during a path monitor or link monitor failure. Okay, so if in case there is a link monitor failure, this will go into tentative state, right? The error state is tentative for monitored object failure. Okay, so as soon as it goes into tentative state, it will not even wait for even a single millisecond. It will fail over to the peer device. Okay, this is what this is: monitor fail hold up time. Additional master hold up time. The time interval that is applied to same event as monitor fail hold up time. The additional time interval is applied only to the active firewall. This timer is recommended to avoid a failover when both firewall experience link and path monitor simultaneously to the same event. Okay, so this is the same event as in when there is a monitored object failure. Okay, so both of these happen during a monitored failed object. So if in case you are monitoring 8.8.8.8 or a link failure, for example, then this will happen. These timers come into picture during that time. The additional time interval is only happening to active firewall in the active passive mode. Okay, this timer is recommended to avoid a failover when both firewalls experiences the failure. So if in case the both of them are experiencing the failure, then this will wait for around 500 milliseconds. If we want, we can read more about this. If we click on this help button, this opens a help page with additional information. I think it should be under general settings, election. Yeah. Yeah. So we can read this as well. So if you do not find any information in admin guide, you can try viewing this help page. So I'd like to keep this as recommended. Okay. I'll disable heartbeat backup because I'm using the management port as the control link. So it's using management. I can enable encryption or keep this disabled. I don't want to enable encryption. HA2. So when I check if there is a port available for HA2, it gives me Ethernet 1.2. Okay. Let me check the lab guide for this. It's given IP address 192.168.10.1, 255.255.255.0. No need to give the default gateway. It is directly connected. So we will discuss link and path monitoring in a while. This is it. Now we'll go to policies. We'll add a simple internet rule and NAT rule. Okay. So you guys are experts now for internet rule. We want to enable a DIPP rule, internet NAT trust untrust dynamic IP port interface address ETH11.
This is for the
That's
Sanmay. Sorry to interrupt you. So we are configuring this source net just because that the internet reachability, right? For this machine. Yeah. Thank you.
Yeah. We will test failover, right?
Yeah. Correct.
If you don't want to test failover, I can skip this.
No,
It
no,
will
no.
be easier for me.
Let's just fail over.
So let me allow any. Okay. Okay. This is it. Let's do a commit and see what happens. Till then, I'll go to dashboard. I'll enable a widget for ac- high availability. Should be under systems. Okay, currently it says that HA not enabled. So someone was asking when the device goes to not ready state. So not ready state will appear at the bottom and this auto commit would be failed. That is when you will see not ready. Okay, I did not enable HA on the peer device. Did I give the peer HA2 connection?
So right now we are in firewall 1 or 2? 1, right?
This is one.
Okay. So we need to configure the same on 2 as well.
Yeah, I actually wanted to show you something. So this goes to active and HA1 is down. HA2 is up. Don't know why. HA2 shouldn't be up. Maybe it will be down if I do a keep alive for this. Keep alive is sending ICMP messages over the HA2 link. That's okay. So what happens when the firewall HA is enabled? It will go to init and then it will go to active. And then this will go to 100.
So Sanmay, if this is the case, then when we are going to perform the lab, it will happen to us as well, right? The lab will go to 100%.
Uh, which rack are you guys using? Do you also see this? Are you able to view the CPU utilization when you work?
Yeah, yeah, yeah.
Okay, so it happens for you as well?
Yeah.
Hmm. I've asked them to increase the CPUs on this server. Let's see when they do this. Okay, so if we go to this passive device and I check the so the HA is not enabled on this. Okay, so if we go to device and let's just I want to configure this Ethernet 1.2 only, okay? Let's go to HA after this. I think we configured 20 as the group ID. Let me confirm. Yeah. So let's configure the group device priority as 110. Port HA1 for management. HA2 would be for synchronization. This would be on ETH12, 192.168.10.2, 255.255.255.0. I don't want to enable config sync on this. So let's disable config sync on this because this will wipe the config on the primary device. This has no config.
Sanman, in our topology, we do have HA1A and HAB ports, right? Means two different RJ45 ports. Then why are we using this management port as an HA2? Is there any specific reason or
No,
why?
we are using management port for HA1 connection. You see, this is the connection for HA1.
Okay, and this is the HA2, right? But we could have used a different port, right, other than management for
Yeah,
HA2, HA1 as well.
yeah. But this is quite common. You will see management port being used.
Okay,
Yeah.
okay,
This is a VM device. This is not hardware device. For hardware devices, you will see dedicated ports being used.
okay, okay.
So this is in pending.
Understand me?
Yes.
Which scenario we will use from management port to Ethernet port for single firewall?
Single firewall? What do you mean by single firewall?
If, for example, I have one firewall, a management port to Ethernet. I've seen somewhere the configuration they're using from the management port to Ethernet channel port number 8. So what is the use of that? Why we are using that? Any idea? Management port to Ethernet port. They're making as a loop the single firewall.
You mean standalone firewall?
Yes, standalone firewall.
Okay, so what happens is, so people want to inspect what is going out of the management port because this is going out to the internet as well, right? This is looking for
Yes.
dynamic updates. Okay, there can be situations where this is infected, right? There was a vulnerability for PAN-OS, right? Anybody heard of Global Protect vulnerability?
Yeah,
GP
yeah, yeah.
vulnerability,
Yeah.
right? So the firewall got compromised, okay? On some systems, some customers got compromised. So what happened, what they want, what some customers want to do, what most customers are still doing is this management port connection, okay? And this Ethernet, any Ethernet port connection. For example, this is 1 by 2, okay? So this and this will do inter VLAN routing, okay? This will be going to a switch. Okay, there will be multiple VLANs over here. One of those VLAN will be management VLAN. Management VLAN. One of those VLAN will be trust VLAN. One of those VLAN will be guest VLAN. Okay, so this will do sub interfaces for that. And this management port IP, the gateway will act as the Ethernet 1, 2. So whatever traffic is going out to the internet, it will have to pass it through the firewall, do inspection, and then only go out of the internet. So they can configure some policies and do layer 7 inspection even for the management traffic. This is the use case for that. Understood?
Yeah. So,
Yeah.
Sanmay, I'm having one question.
Yeah.
Okay, but that is related to side VPN. So, is it a good time to ask? I can see the CPU is 100%, so that's the reason.
It just went to 50.
Okay, fine.
Just wait for this lab, okay?
Okay.
Okay, let's go to dashboard. Let's see if this, okay, so this went to passive, right? Okay. Now there is no config on this peer device, right? So we do a sync to peer. We will send the config from the active firewall to the passive firewall. Config sync in progress. Mhm. Okay, so you see this went to synchronized. So if I go to this firewall and see, this will change to synchronized. All of these are green. If I go to policies, I did not configure any security rule or NAT rule over here, right? So this was auto pushed from the primary firewall. If I go to network, I see that DHCP has been configured, but it doesn't have an IP yet. If I go to this has an IP and it is in bound state. Okay. So you see how this is in green, right? And if I go to this firewall, this is in red. So this is what happens when the link state down is configured. So you see passive link state shutdown. So this means that the link state will be in down state when this firewall is in passive mode. So if I change this to auto, you will see that these should change to green. This enables fast failover. Usually not recommended when we are using upstream and downstream layer 2 switches. Okay, so usually recommended only when we are using layer 3 switches. In our environment, we are using layer 2 switches, but I still wanted to show you how this works.
So I have one question here. So you configured the interface as DHCP client, right?
Yeah.
So from where it is getting the IPs? Where is the DHCP server?
This is a virtual server, right? So it is using a common ISP connection, I think. So through that, it will fetch the DHCP configuration.
Oh, but it's using the private IPs, right?
Yeah.
Yeah.
So it should switch to.
So we can even give manual IPs, right? I mean static IPs.
Uh, I don't think so. It will not work. It will work if you see the range over here, and then you can bind it over here. But
Yeah,
if
that
there's
will
an
work.
IP, yeah, if there is an IP conflict, then there would be a problem. Let me do the passive link state on active over here as well. Could be due to the link state maybe down on the switches. These are not coming up. The switch is up. A config committed. This is still down. This should be up. Configured, but down. Because this is the point of keeping this in auto. Not sure why this is showing us down. Anyhow, let's move forward. Let's see how the failover works, okay? So if I go to this device, saying google.com hyphen, okay, this will not work because this does not have uh, IP address configured. Change adapter. Let's see what network we configured on. Ethernet 1.3. Hmm. So we go to this firewall, go to properties. We'll resolve. Okay. Now let's do a failover. How to do a failover manually? We go to op commands, under device high availability, we go to op commands, operational commands. We will do suspend local device for high availability. Let's do this and see if the failover works. You see one ping miss. Now this ping miss, you guys will think there will be disruption. How much traffic is UDP and how much traffic is TCP in the network? Think about that, right? TCP can be retransmitted. If I were to use this on a browser, I would see no disruption in the network. I wouldn't even realize there was a ping miss. Okay, so we can make this device functional again and see. This is in init. Now this will go to passive in some time. Yeah, this is going to passive. So we'll come over here and again, let's just see this network if this interfaces are up. You see, this is in passive, but the interfaces are still up. This is how it should be. Passive link state auto. This is in passive. Now, this is the primary firewall. We will again fail over. Should be single ping miss, maximum 2. Okay. Some issues. Okay. Now we see that the network is up again. Can make this device functional again. Could be due to this. Okay, let's go to this device. This is in active again. Okay, so this is how you test a failover. Okay, link and path monitoring. So we can check for any link failure. Okay, so we can check for link fail. Let's do downstream actually. So if in case this links fail, then this should do a failover, right? We can also do this path monitoring, right? So we can add a destination IP, like we said, 8.8.8.8, and we can do a ping. Okay, you can try this out as well. But let's just do for link failure. I can add multiple links as well. Okay, so if I add multiple links, for example, I added one Ethernet one as well, upstream. So if I check this edit, there is failure condition any or all. Okay, so if I do all, then when both of these will fail, only then the device should do a failover. When any of the below will fail, this device should do a failover. Okay, this is what it says. Let's see if we are able to shift the traffic. This might not work because let's see if this would work or not. We have a downstream switch. We will try to shut down this gig 0/0 and see, okay? Cisco experts, help me out. I have no idea how this works. When this comes down. Okay, till then, what IPsec question it was? Someone was asking IPsec question.
Yeah, Sanmay, I'm having one question regarding the IPsec.
Mm-hmm.
So actually, I was doing an IPsec VPN, site-to-site VPN between AWS and Palo.
Mm-hmm.
Okay, and the Palo is also hosted in AWS as a VM machine.
Mm-hmm.
Okay, so the outbound interface is a public IP. Okay, it's a by two. That's a public IP being connected to AWS VPN, and in that IP, it's like it got the IP dynamically, like the same way we were doing, right? It's via DHCP. So my question is, while configuring site-to-site VPN in the I gateway, if it is a DHCP, we cannot manually add the local interface IP, right? It will be dynamically, correct? In the I gateway, I meant to say. So when I'm taking that interface as in the I gateway, so it is
Mm-hmm.
taking the private IP, not the public IP. And if it is not taking the public
Yeah,
IP, then
on the local, it should be it will only be the IP assigned on the firewall's interface. So
correct,
if it is on a VM device, it will be private IP. All the IPs on the firewall will be private because it's behind the AWS infrastructure, right?
absolutely, absolutely.
So you have to
Mhm.
use NAT reversal for this. So there is an article for Palo Alto. I will share you that, okay?
Yeah, yeah, please. Because the thing is, I'm checking the system logs, okay, and it is giving me only the private IP negotiation, the IP negotiation, I mean to say, and it won't work, right?
It won't work. You have to use NAT reversal for this. There is additional config for this.
So yeah, in the I just need to enable the NAT traversal in the advanced tab, or how is it?
There are other config as well. You have to do local ID, peer ID as well. Because the identification fields would change. They would not be
Yeah.
able to authenticate.
Okay. So in the local and the peer ID, what should be that? The NAT IP, I mean the public IP, and the peer ID is the same, like it's the other end IP, right?
So what is this? I will give you the article for this, okay?
Sure, sure, sure.
Gig 00. Okay. How do I do the shutdown? Is this
No,
it?
no, no.
No,
You
no,
need
you
to
have
go
to
into
go.
the interface. Under the interface, in the interface mode, you can do that. No, go to the config mode.
Okay. Config,
Terminal.
config,
Configure terminal. Yep.
and
Go to
then
the interface. Interface. Yeah, gig 0 by 0, whatever is that.
0/3, I guess.
no, it's downstream, gig 00.
Yeah.
Yeah, 0/0. Okay.
Use the
Then
command
I do
shutdown.
shutdown.
Shut.
Yes.
Exit WR.
No, it would
And
take effect, right? It would take effect.
correct.
Yeah, yeah, yeah.
There is no commit in Cisco switches.
No, no, there is no commit, nothing.
Let's see if this fails over. No, so for some reason this is not going down.
No, after executing the shut command, can you please go to the switch and check whether the interface has gone down really? Yeah, it gone
Yeah.
down. Yeah, it went down. Hmm.
Gig 00. Hmm. Yeah,
And
could
these
be.
firewalls even connected to the switch?
Yeah,
That's the
yeah.
question now.
This is the topology.
Yeah, but if one end of the switch is shut down state, the other end should automatically go down, right? There won't be any negotiation happening.
Yeah. But this is a VM environment, so could be due to that. So if I manually make this down, this will not work. I have to make sure that the switch end is down. Only then it would work. But even this is not working.
So one question, Samma here.
Uh-huh.
So the task that we are looking here to sense the physical link down or the reachability, because there are two things. One is the reachability, one is the physical link
Physical
down.
link down. Physical link down.
So reachability won't consider as down in the path monitoring. I mean,
Yeah,
we
yeah,
are
it
checking
will
the path
also.
monitoring, right?
No, we are checking link monitoring. There are two types of monitoring, you see, link monitoring and path monitoring. So we
Okay.
configured link monitoring. So if in case 1.3 goes down,
Uh-huh.
make a switch to the other device. Let me
Okay, I will.
see, do a ping again. The link is down, but this is not working. For some reason, this is not doing a failover.
Can you check for the path monitoring ones?
What do you want to check?
Yeah, so I meant to say, can we look into path monitoring once?
Like configure path monitoring instead of link monitoring.
Yes.
How will we block the traffic then? Can we configure ACL on switch?
No, we will remove the IP address, right? We'll remove the IP address, so it will cause the traffic to block, right? Anyway.
That's okay, but we want to test it, right? We want to test it.
So in the lab guide, is it the same step are we referring?
So lab guide is built by me, buddy. Let me check. I think I have not configured or shown this in lab guide. Lab guide is for uh, doing the failover. This could be due to that this environment is virtual. Maybe due to that this is not going down.
Can you go to the HA once again?
Yeah.
Yeah, in the path monitoring, if you just
Mhm.
add that, okay, means path monitoring will check the reachability, right? Link group will check the physical link and the path monitoring will check the reachability, right? If I'm not wrong.
Mhm.
So in the path monitoring, you are going to check the upstream reachability like 8.8.8.8 or what?
Yeah.
Okay. So in the 8.8.8.8, if we just block that connectivity towards 8.8 without bringing anything down, it will sense it, right? So it will do what? It will test on the basis of ICMP or what will be the probe to check the
ICMP, but
reachability?
where will we block it? That's
Yeah,
what that's what I'm
yes,
asking.
yes. Go
Can
to
we
the,
block it over? Can we block
Mhm.
it over on the switch?
Absolutely. We can, if we just, I mean, yeah, in this, see, upstream is from the active to the internet. That would be the connectivity.
Mm-hmm.
Okay. So in the switch, is it a layer 2 switch or layer 3 switch?
Layer 2.
Okay, so we can, right? We can bring the gig 0 by 0 down. Yeah, it will monitor, it will bring it down, right? Means the upstream connection from the switch to the internet is via gig 0
Then
by
both
0,
will
right?
go down, right? Even the passive device will not be able to reach 8.8.8.8.
No, but currently the active is the one which is doing the path monitoring, right? So it will do a failover to passive because even which one will do the path monitoring? If you configure the path monitoring and
This one.
active, this one.
This one.
So if it is not able to reach, then it will fail over to the passive one or not?
It should, yeah. It should do a failover right now as well. But this
Yeah, but
virtual
as
environment is killing me.
correct. As we are not able to see the link down, so that is the reason I'm thinking that if we can test that.
Okay, let's do that. That's okay. Mm, Google Ping. So the agenda was just to give you a failover up till failover. The lab is up till the failover, not for link and path monitoring, because in virtual environments, this link and path monitoring, this doesn't work properly. Just the link monitoring does not work in virtual environments. I guess we'll go to, let's make this up actually. We go to config T, right? And then interface
Gig
with
0 by 0.
user 0 and now shut. It already went down, non-functional, path down. Okay, guys, the lab is quite high in CPU. I don't think I'll be able to do this link monitoring lab with you. Um, let's close this lab. Practice link monitoring by yourself, I would say, because I'm having troubles with this.
So Sanmay, once we configure that path monitoring, this device went down, right? Because of the
Mhm.
reachability or what?
Yeah, because of reachability.
So can we check the standby whether it has taken the active one or not? Active role?
Yeah, you see over here it is coming as active.
Yeah, so it's working, right? I mean,
Yeah,
can you again try to bring it up and check?
that's what I'm saying. I'm having troubles with this CPU issue. I want to finish the active as well today. Won't be able to do it. Okay, this is passive. We can check the system logs for failover. HA event, move from active to non-functional. Alarm cleared. Let's see if there were any alarms we see. Maybe this is not licensed, so we don't see alarms. Path monitor down, you see.
Yeah, it went down.
So you can track system logs for this. Okay, so play around with this link monitoring, path monitoring, but I would suggest it works better in real-time environment, not in virtual environments. Okay, some things are made for real-time environments. Okay, I'll close the lab, guys. This is for the active passive.
session, right?
Yeah.
I have a HA1 and HA2 active and passive. Even though whether I'm able to connect backup firewall or not. Can you, if yes, can you just explain me how it will work?
What kind of? I
Backup
didn't
firewall.
understand the question.
Okay. The scenario I have two HA1 and HA2, the two firewall.
Mm-hmm.
Okay. Still, whether I can connect the backup firewall or not. Backup firewall.
What do you mean by connect? That's what I'm asking.
Backup firewall.
What do you mean by that?
What is my question? The HA1 and HA active and passive for mainly for the failover connection. So even though still we can connect the backup firewall means if in case the both is down, that case we can use the backup firewall.
What-
I'm asking you the question. So whether is it if in case the both firewalls went down, so what is the case of we can connect backup firewall? Is it possible?
So you
The
mean to
additional
say,
firewall.
HA1 and HA2 active and passive. Now
Yes.
both the devices went down, you're saying.
Okay. Yes.
That's what you're saying.
Yes.
So we need to have a spare firewall, right? If we have a spare firewall, only then we can put it in the network. Now, for adding a spare firewall in the network, we need to have a config from the active device, or the passive device will also work. Okay, so if we have the config, load the config on the spare device and then put it in the network the same way.
Okay.
Okay, active. Now, active is not meant to increase throughput or performance. Does not load balance. Only use case is asymmetric routing. So if you have asymmetric traffic flow in your environment, only then use active. Otherwise, active passive is always the better option for you. Okay, in active scenario, one firewall will be, there are two new states then. Okay, we discussed states, right? So this will, one device will be active primary, one device will be active secondary. Okay, there will be three links connected from here to here. HA1 control link, HA2 data link. There will be another HA3. This is only for the active setup. Now this is for handling asymmetric traffic flow. There is a concept of session setup and session owner in active firewall. Now, session owner can either be one of these two. The firewall that receives the first packet for the session, or the active primary firewall. This will be responsible for your layer 7 processing. In active scenario, the jobs are divided. This will be doing your layer 7 processing. What is layer 7 processing? App ID, your content ID, it is also known as CTD, threat scanning that comes in threat ID, content ID. So all your layer 7 processing will be done on this. This will also be responsible for creating logs for this. So traffic logs will be generated on session owner. This will be responsible for generating traffic logs. If in case session owners goes down, the traffic will be shifted to the peer device and no layer 7 processing will happen for those sessions. Session setup. Session setup, this is responsible for processing from layer 2 to layer 4 processing. Okay. Okay. These are the details required for setting up a new session. Okay. Now address translation happens on this device. Session setup. Now session setup is evaluated based on load sharing algorithms. It can either be primary device, firewall who receives first packet, IP modulo, or IP hash. Clear? Session setup and session owner. What is the difference? Session owner does layer 7 processing, app ID, thread scanning, etc. Session setup, who sets up the session, does address translation. Okay. This is determined first packet received or will be primary firewall. This will use load sharing options along with primary device first packet, IP modulo, and IP hash. Let's understand traffic flow. For active. First will be, for example, you received a new session. Okay, let's assume that this is the firewall connected to this firewall. This is device A, this is B. Okay, this is a switch, this is a switch. There are upstream switches as well. Okay. Now, this can be the internet, and these will be your clients. Let's just assume that there is a client. Now, this is trying to reach some application on the internet or somewhere. It sends a packet. Now, device A will see that this packet belongs to a session, existing session or not, or if this is a new session. If there is a new session, if this is a new session, device A will see, okay, this needs to set up the session now. Now, based on the algorithm, primary device, first packet, or IP module or IP hash, this will determine whether this should set up the session or this device. Let's assume that B is the device who will do the session setup. Packet received by A, but B will do the session setup. So A will send this first packet to device B over HA3 link for completing the session setup. It will set up the session. Layer 2 to layer 4 processing. It will set up the session and then send the traffic back to device A. This will be the session owner. Now this will do layer 7 processing. Inter firewall communication for traffic is done over HA3 link for session owner and session setup. So this packet gets received by device A. It will do layer 7 processing and send the traffic out to the application. Any questions? This is for new session. Device B will be session setup. Device A will be session owner. This will do layer 7 processing. It received the first packet, sent the packet to device B. It sets up the session, sends the traffic back again, sends the packet back again to device A, does layer 7 processing, forwards the traffic out.
Sanmay, one question. So, if both it's the active setup, so what kind of connections will be in both the firewalls? Will be the edge links, right?
Yeah, we just discussed, right? HA1,
Mhm.
HA2, and HA3.
Okay, okay. Okay.
Okay, this was for new session. Now, what about existing session? Device A, device B, similar kind of setup. There are switches over here. There are switches over here. Client for the network. This is the session owner. This is the session setup. It sends the packet. Now it will see, the device A will see that this belongs to an existing session. Does it need to send out to device A for setting up the session? No. It will do layer 7 processing and forward the traffic out. Existing session, simple. Asymmetric flow. There are two types of asymmetric flow. One is L3 and V wire. Okay. Now, one more thing I missed is this active-active deployment can only be done in V wire or L3 mode. This will not be supported in any other mode. Active passive is supported in all modes, layer 2 mode as well. Asymmetric flow, similar kind of setup, device A, device B. Okay, now the packet was sent out from device A. The receiving packet is coming on device B. This is what asymmetric flow is. Now device B will receive this packet from the application. This will see, okay, I have a session for this, but I'm not the session owner. It is owned by device A. In layer 3 deployments, this will forward to device A. A will do layer 7 processing again and forward this packet out from device A in layer 3 deployments. If it was vWire deployment, this is the fourth scenario. Asymmetric routing, asymmetric traffic flow in vWire deployment. In vWire deployment, we do not do routing. There is no IP or MAC forwarding on firewalls. B will be session setup. This will be session owner. B received the packet. It will see, okay, I am the session setup firewall, but the session owner is A. It will forward the packet to the A firewall. A will do layer 7 processing, forward the traffic back to the B firewall, and B will forward to destination. This is to maintain inline symmetry because we do not do traffic changes in vWire deployment. Got this point? Any questions in packet flow for active-active firewall? Easy. It's just that there are new things that active-active brings to the table. Okay. Now there are deployment types. Deployment types can be either layer 3 or vWire. If now, of all the deployments I have seen, 99% are active passive. Only 1% is active active. Out of those 1%, 90% will be vWire. Rest 10% will be layer 3 deployment. So layer 3 deployment is very rare because this is the most complicated type of deployment for Palo Alto. There are multiple types of layer 3 deployment, but just one type of vWire deployment. There is floating IP, ARP load sharing, and route redundancy. There is one more mode called mixed mode. Now this combines floating IP and ARP load sharing. Give me a second, guys, okay? Okay. Now let's discuss vWire deployment. Now this is the simplest solution. Firewalls are installed between layer 3 devices. Okay, no routing, no IP, no MAC. All of this is controlled by upstream and downstream devices. This will be active, active, primary active, secondary active. Clients. Now you can run OSPF or BGP over here and then choose how you route the traffic between your environment. The firewalls will be able to handle asymmetric flow. So we discussed how it handles asymmetric flow in vWire. Okay, this is only supported between routers. Now let's discuss layer 3 floating IP. Layer 3 floating IP is also known as VRRP type like deployment. This is usually between switches. Primary active, secondary active. In this, your Ethernet, suppose this is Ethernet 1, 2, and this is Ethernet 1, 2. Okay. This is ETH 1, 1, and this is ETH 1, 1. The subnet over here is each interface will have a unique IP. Each interface will have a unique IP, layer 3 IP, 172.35.2.252/24. Okay. Now this will have same IP, but 253/24. There will be floating IP against this. There will be floating IP against this. Okay. Let's say floating IP for 253 is 172.35.2.100. The floating IP for this is 172.35.2.101. The client's gateway will be one client, half of the clients will be having gateway 100 and half of the clients will be having gateway 101. If in case one device fails, the floating IP will be moved to the peer device. Okay, this is floating IP deployment. And the GR will be sent from the currently active device to update the MAC table. This is floating IP deployment. Second is ARP load sharing. In ARP load sharing, this is still sandwiched between switches. Each interface will have unique IP. Okay, this will have unique IP, exactly same as the floating IP. This will have unique IP, but the IP will be shared between these. So there will be no separate IP for each interfaces, but shared IP between these. One 172.35.2.100, for example. This will be 252 and this will be 253. The clients, all of the clients will have gateway as the shared IP 2.100. Okay. This will have a separate VMAC. This will have a separate VMAC. VMAC is virtual MAC for the shared IP. Now, this will use an algorithm in order to determine which device will respond for the ARP request, because this will generate a ARP request to send the traffic out. This is done using the hash of source IP. Okay, it uses an algorithm computing a hash of source IP who generated the ARP request. So it's an internal algorithm. If in case one device fails over, this will take over the role of all the firewalls all the clients gateway and send out a GR in order to make sure that this is all the devices are sending upstream traffic to this device. Okay, and this can be done on both sides. Okay, now this we only discussed from downstream, right? This same can be implemented upstream. This will be shared IP, right? And over here, even upstream will be separate floating IPs. Separate floating IPs. Mixed mode is one side you are using shared IP and one side you are using floating IPs. This is known as mixed mode. Okay, downstream the gateway will be same. Upstream it can be different. Okay, you can see how this complicates the deployment. So the easiest way to put in a active firewall is vWire deployment. Last and final is route-based redundancy. In this, each interface has a unique IP address and is sandwiched between routers. This will run routing protocols between each other. So even firewall will run dynamic routing protocols. These are the type of deployments for active scenario guys. Let me quickly check what else. Okay, this will be shared to you by the end of the class. We discussed design purpose, HS states we have discussed. We discussed what session owner is, what session setup is, and the packet flow as well. So go over this video once again, guys. Active can be quite confusing. Go over the video one more time as to understand the traffic flow as well. Okay. Active passive we discussed, link monitoring, path monitoring we discussed, but unfortunately this does not work in virtual environments, in this virtual environment. HA timers, states and interfaces, all discussed. Active deployment modes, we discussed floating IP, rpload sharing, mixed mode, floating IP plus rpload sharing and route redundancy. Okay, what are the difference between these? Okay, we will not be able to do deployment for this, guys. This will get too complicated and is much higher level than the PCNSE exam. Before we wrap up for today, I have a small activity. Some of these questions we discussed previously, but we'll discuss these again. Can you guys tell me what are the different modes of IPsec that are supported in Palo Alto?
Main mode.
Policy based and route based.
So IPsec in Palo Alto is just route-based VPN. We are
Yeah.
route-based VPN. We are not policy-based. Backward compatibility is there. But in modes, I was asking IKE V1 and IKE V2.
Oh, yeah, for the version.
Yeah. Okay. Where does defragmentation happen in packet life in Palo Alto? Do you remember packet life? Ingress, slow path,
In the egress one, right?
fast path. In fast path, there are app ID and CTD, right? App ID, CTD, and then we have egress. Where does defragmentation happen? Egress or ingress?
Egress, I believe.
Ingress.
Where one or two?
One.
One.
Defragmentation.
On egress.
Yeah. What link is responsible for maintaining config sync in HA? What link is responsible for this, guys? We did config sync activity today.
I guess it's HA1 link.
Yeah. HA1, control link.
Yes, HA1.
How to configure IPsec with Cisco ASA?
What is this question? How to configure
Using
IPsec?
proxy ID.
Yeah. Proxy ID.
Proxy.
What is U-turn NAT?
Again, if we want to access internal server with external IP or public IP, we need to do source and destination net both.
Yeah.
Basically, source NAT and destination NAT in the same scenario.
Yeah. What is the difference between universal and interzone security rule?
Universal default.
Yeah.
In interzone, by default, the communication is blocked, and in universal,
Traffic is allowed within all zones.
It is allowed here.
Yeah. So in universal, A to A, B to A, C to A, C to B, all of these are allowed. Intrazone is also allowed. In interzone, if we have this, only A to B, B to A, C to A, and C to B will be allowed. Intrazone will not be allowed in interzone. Next week, Global Protect. Okay. This is it, guys, for this week. It was a very heavy class, I would say. Could be for you guys as well. Watch the video once again. We will not be having next week's class. I am traveling next week. So next week's class will be dismissed. I will drop a note in the chat as well. Okay, sorry for the inconvenience.
Sunday, Saturday, Sunday, both or only Saturday?
Saturday, Sunday, both. So next weekend I am traveling, so I won't be available next weekend.
Hi, Sanmay.
Yeah.
Have you shared this PPT in the WhatsApp group?
This PPT, not yet, because there are some topics that have not been covered. So I don't want to confuse and get on some queries which on the topics that are not discussed. So this PPT will be shared once the class gets over.
But in future you will share, right?
Yeah.
Okay, thank you.
Sunday, one thing more.
Approximately.
Sunday,
Go ahead, please go ahead.
is it possible to increase the RAM of the VMs, because I have checked, they have allotted only 4 GB of RAM, due to which we are facing a lot of slowness in the labs.
The slowness is actually due to CPU being overutilized.
Yes, CPU is also, and the RAM is very low as per the requirement. It should be at least 8 GB RAM.
For the VMs?
Yes.
Okay, I'll check if I can increase that. I should be able to increase that. But we are seeing issue due to CPU
And
utilization.
because I have done SD-WAN also from NW Kings. At 4 GB, the lab after some time it gets stuck up due to low RAM allocation.
Okay, so the Palo Alto VMs work differently, guys. Could be due to a different scenario, different issue. But yeah, let me see if I can increase the RAM. That's not going to be a problem.
Okay.
Sunny, can you please help me with that side-to-side VPN talk that we were discussing?
I'll share that in the group, okay?
Yeah,
Everybody
please.
will benefit that.
Thanks.
So, Sunmay, approximate by which date we can, cover the entire session? Any idea?
So the topics left for the firewalling are Global Protect and User ID, and then I have Captive Portal and Decryption. 2 sessions for Global Protect most likely, and 2 sessions for User ID. That would be 2 more weeks. 1 session for SSL decryption and Captive Portal is enough. I believe it would take 4 more weeks, somewhere around that. 3 to 4, either 7 to 8 sessions more, because I have to cover Panorama as well. So 8 more sessions.
So are we going to see any URL filtering or all those things?
Yeah. During SSL decryption, we will discuss URL filtering, or URL filtering will be discussed at the end, because URL filtering license is not available in the lab. But I have my own personal environment. I will show you how URL filtering works on that. You guys can spin your own VM on AWS that will have a URL filtering license.
Okay, thank you, Sunny. Yeah.
Thank you, guys. Take care. Bye bye. See next week. No class, guys. Take care. Enjoy your weekend.
Thank you, Sanmay.
Bye.